Um, can I try?
Yeah, you can.
Okay. From what I could, under all this under future engineering that we did before, we did something like tokens. Ah, I'm trying to remember exactly. They were like something like tokens. So there was a statement that they made that they were like regular expressions can be used to define patterns for splitting text into tokens. Is that correct? Hello, can you hear me?
Yes, I can hear you. I'm trying to check my. Okay, my mic is on.
Um,
Um, mm, you're not right actually because that one is for tokenization. That's like a different thing.
okay.
Yes. So regex is basically to filter and sort through text. Um, like for example, when you go on your screen, right? I don't know. For those of you that have your system, if you go to your folder, right, you have like uh let's say you try to enter a file or maybe a folder, there's this place up that shows you from what folder to what folder you get to. For example, now you go on your desktop, you open documents, from documents you open probably ML projects, and then if you click on that um top bar, you see something like C hash slash maybe user and all of that. All those things are like all those slash column C, they're like regular expressions. Basically what they help you to do is to filter and sort through text. So I'll be sharing my screen now to show you guys a much clearer example. And please, I need responses. I beg. Like it is very important because if I'm teaching you guys and I'm not getting like feedback or responses, then it means that you guys are not learning anything. That's just what it means, and it doesn't make any sense. So if you can see my screen, you can react. React if you can see my screen. Just keep people reacted. Okay. Anyways, let's just go. So this is this is like a quick quick uh let's give it a second. All right, so this is like a quick workflow of NLP basically. So we have our data, and the data is hotel reviews. Let me start from the beginning where I imported it. Okay, so we have our data, which is hotel reviews, and I imported the data from here. And so there's one thing about, let me check. Okay, so this data is an hotel review data. What this data basically has is it has the reviews and ratings for a particular hotel. So people come in there and they drop their review and ratings. It's just like when you go on Play Store, you download an app, another app, you can always drop a review of what you think about the app and the ratings. A lot of times, this information are very important for the organization of company or application for them to be able to know what to improve on. So you as an ML scientist, your job is to be able to understand what are the important things in that data that you can use to know if your company is doing well or serving the customer well. So first off, we check the info as usual. We try to do like EDA, try to check, okay, what kind of data is this? And from what we can see here, we can see that it is an object and also an integer. So the object is basically the review and the ratings is an integer. It basically just has two features, which is review and ratings, because that's the only thing we need. And so we check for value counts, and yeah, these are the value counts. The only value count that exists there for ratings is 1 to 5. So you can only rate from 1 to 5. And from what we can see here, number five has the highest count, which means that the hotel has a really good review and a lot of people like it. And for people that got like one are just very few. They are like times three less than of people that picked five. So now, first thing you do when you're working with NLP is you need to change everything to lowercase. Now, the whatever data you get, a lot of times in real world data, we always have uppercase, lowercase combined together. But you can always turn everything into lowercase, which is why we create a new feature. As you guys can remember feature engineering, I taught you. So these are another example of feature engineering where I created a new feature, and in that feature, every single text or every single letter are in lowercase. Now, that's the first thing you are doing. You are doing general cleaning. So um hmm, so after we turn it to lowercase, we import stop words. Now what stop words? Now stop words in English are not like important to us a lot of times when we're trying to train an NLP model. So there is a what's it called? There is a we have like a data set kind of that has like a list of these stop words. And for us to get that data set, you need to import NLTK rather, then you download the stop words. So the stop words you can select the one you want, which is English. So that's exactly what I did here. That's exactly what I did here. So no no yeah. So out of all the stop words, I said okay, let's not remove not like let's remove not from the stop word. Now, this part of the code, what it's basically saying is uh we out of all the stop words that is contained in this English, right? We don't want not to be part of them. We need not. So let's remove it from the stop words. That's why it is like this. So we remove the stop words using this code and we add a new field. Now, let me explain the code. Now, this code is basically a function, but like you're applying it, it's a lambda function. Now, a lambda function is a way you add a function into a particular list of or arrays without needing to actually like write the function the normal usual way. So the best way is just okay, use this method apply. So when you are using apply, what you are saying is okay, for every time you go through this list of arrays, I need you to do this particular thing. Now, what do I need you to do? I need you to check, right, for I need you to split the word. Okay, I need you to join the word first and then split it. Now, after splitting it, I need to check if the word has a stop word. Now, this is the stop word here. Now, if it has a stop word, I need you to remove it. That's what it's basically saying. So, if it does not have a stop word, then remove it. So, so from here, if we check, if we check this data very well, we have this nice hotel. Okay, so this is it here. So from here, I wrote a code to actually check if you remove stop word. So I printed out the normal review, which is this, or the first normal review. So it says here, nice hotel, expensive parking, got good deal, stay home anniversary, blah 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 blah, all those stories. But then when we look here, if we notice like there are some certain things that are not there. For example, did is not there. Now, if you guys see this now, I highlighted did, and if you look at this place, it just said took advice previous reviews, valet parking. Now in this place, it said took advice previous review, did valet parking. You removed did, just put valet parking. That's an example of like removing stop word. Now, removing stop word is basically like data cleaning or like you're cleaning the sentence. Now, the next thing for you to do is to remove punctuation marks. Now, when you're removing punctuation marks, well, it's still the same thing. You apply like a function to it, and what's that function? So this is an example of regex. Yeah, this is an example of regex. Now, this R simply means raw to make the text raw. Just give me a sec. Before I even move on. before I move on, please, if you are following me, can you give a thumbs up or leave a message or stuff? Right. Let me know that you understand. Just one person is replying you. What's happening, Abeg? Ah, only three people replied. Something is wrong. I said, something is wrong, bro. If you don't understand anything, drop a message or you can unmute and interrupt me. I don't mind. Even if like you've not done NLP before, this is actually like a really nice way to learn. It doesn't matter if you know it or you don't. Like you can always learn from it. So let me just move on, shall I know this? So yeah, I was explaining this part, which is like an example of regex. Now this is an example of regex. In this regex, what we are doing is we are basically filtering out some certain things. Uh, but yeah, we are actually selecting a point. So in this part, we are saying, okay, take the star. Anywhere you see star, because if you guys can look, you see star in this place. This four ash, there's a star there. So what we are saying is take this star and then change it to star. That's basically what this code is saying here. So anywhere you see star, instead of the normal hash asterisk, it uses star, like as in STAR. So if you look at this place, instead of instead of this star here, it uses STER. So if you guys can see, there's a star here in this pole, and then now I remove that star and put star instead. That's just what I did, physical, like nothing complex there. So this is just regex. So to import regex, you can import regex as RE, and then regex has different method. It has the search method, it has the remove method, it has the append method, it has substitution method. So I just use the substitution method here. That's basically what I just did. And then after like changing star to star, now what did I do here? I this place I tried to remove punctuation marks. Now, not just punctuation marks, but punctuation marks and white spaces. Okay, no, no, not white spaces. Sorry, that was wrong. Um, yes. So this W right here, what it basically means, I mean, this hash here means that start of a start of a sentence. Okay. So this one here means start of a sentence. Now it's saying, okay, check through the start of the sentence. Check anyone, but except white spaces and a word. So what I'm doing here is I'm looking through a sentence. Let's say the sentence is a the quick brown fox jumps over the lazy dog. Are you guys listening? So now I say, okay, the quick brown fox jumps over the lazy dog. Imagine there's a comma, or there's an asterisk, or there is a semicolon, or there's a colon, whatever like punctuation it is. I said you should take those punctuations, right, and then replace it with an empty space. Like don't put anything there. But you check through this sentence, leave the words that are there and leave the white space. So W just mean word and S mean white space. And this stroke, is it right stroke? I think it's right stroke. Right stroke there just means except or not word, not space. That's also what it means. So you guys can actually check out regex, or we can even go through it here actually, so that it's something that you understand. Or before I even go on, do you guys suggest I look through what Regex is, or we should just move on the NLP? I just want us to like flow. I need responses.
I think it's better we should look through Regex.
Okay. Okay, we should move to Regex. On stop words. Okay, I'll explain. Don't worry. So you guys will understand when you look through Regex. So I'll stop sharing my screen and I'll share like the screen for the Regex parts. So normally regex is a normal like code is a normal like code we use on any kind of programming. But it's not just for machine learning, but it's just used to help to filter words. So currently I'm in Geeks for Geeks, and in Geek for Geeks you can always like learn new stuff there, like terms that might be confusing and all of that. So from here, they said regular expression matching is used to tag words. Consider the example. Number can be matched with slash, right slash D to assign the tag CD, which refers to cardinal numbers, or one can match the known words such as suffix ing. So all those ones are just story, to be honest. They are just story. Let's just check through this part now. So here's a Python regular expression module and RE syntax. So we have R, and then we have like our normal quotation marks with this up arrow and then slash D plus dollar sign. Now, all these things are not just they actually have meaning. They actually have meaning. So I think they are supposed to put like the words it's trying to filter out or the pattern. First tendency to with your regular expression. Second using time. Okay. I'm trying to look for where they put meaning for each of these stuff. Because if I'm just saying it, you might be confused. I searched for the wrong I searched for the wrong thing. Okay. This is what I was supposed to check. That was the wrong thing actually. Alright, so these are regular expressions. So in regular expression, they said to work with formal language and string pattern, it's essential to understand regular expression, regular grammar, regular language, and blah blah. Regular expression are symbolic notation used to define such pattern in strings. So regular expression are mostly used in strings, like words and all of that. So let's see, what is this thing? Okay, this is not the regular expression I'm looking for. This one is regular language. Let me stop sharing my screen, check for it, and I'll share it. Just check. All right, I have finally found the right thing. Was what the hell? Mhm. Okay, I found the right thing. Yes, I found the right thing. I'll share this screen to it, All right, so this is like regular expression and what each of those like symbols mean. So the symbols that I was showing you guys on my code was basically like asterisk and this arrow up symbol with WS and then R. So there's this one which is this like arrow up symbol. So arrow up symbol is called okay, is a tree, a carrot. Okay, a carrot symbol. That's what it's even called. Carrot. So carrot symbol tells the computer that the match must start at the beginning of the string. So whenever I use a carrot symbol, what it means is okay, let's start from the beginning of this string to check for a pattern. That's what it means. So we have the dollar sign symbol. So dollar sign symbol tells the computer that it matches must uh that the match must occur at the end of the string or before slash n at the end of the line. So a this one is just to say, okay, let's end at this part. That's what it means. The dollar sign symbol means end of a string. That's just what it says. And then the caret symbol means let's start from this place. So yeah, so these are the character classes that I was using. So this one says matches a word character. The W I was using, this is what it is. And then the S I was using, it said matches any white space character, such as white space tab. This is it here. And then there's D, which one? This one is just for digit character. Why capital letter D is non-digit character. And the capital letter W is non word character. So yeah, all these symbols like mean different things. So for the for this one, if you want to match the actual plus character, okay, search. They are just different type of character actually, and each of them are used for different things. So we have this question mark hash. This one is just for comments. It's an inline comment, and then we have back reference. It allows previous match sub expression to be identified subsequently in the same regular expression. So if you remember, I was using slash W slash S. What I was basically saying is, okay, identify word, identify space. That's just what it does. It just like gives space in between. So I'll stop sharing this for now. Um, you can always check out regex, actually. You can always check out regex. It's more than just the symbols. The symbols are just how we express them. But they have like methods and functions like I said, you can use it to search for words, you can use it to substitute words. So that's basically what I'm doing here. So if you can see here, this place means start from the beginning of the word and then check for the word and white spaces, but exclude them. I don't want you to do anything to them. But any ones that are not like that, I need you to uh make it empty, the ones with punctuation marks. So that's just what I did here. I just removed punctuation marks. So yeah, this one I just used to check if okay, yeah, I just removed quotation mark here. So the next thing for you to do is to tokenize your word. Now in tokenization, what you are doing is you are trying to take the sentence and turn it into individual words. So for every word in that sentence, you are making it to be just one individual word. So that's like we're taking a sentence and we're putting it in an array. But in that array, each word is on its own. Each word is on its own. So let's say now this is it. We have nice hotel, expensive parking, God's good. So normally they are in a sentence here from here to here, which is like the lower case, the no stop words and no stop words and punctuation. But then here I just put it in an array. That's what this does. And I added it into a new column, which is the tokenized column. And after tokenization, The next thing to do is you need to stem the data. Now in this one, this is where removing noise from data comes in. This is where removing noise from data comes in. So we clean the data. You clean the data. Now we are trying to remove the noise. Words that are kind of repeated there. So what stemming does is it reduces words to their base form. Now, um, here's an example. We have learning. What are you guys? You guys are currently learning, right? And in learning, the base word of learning is learn. But at the same time, you guys are learners. You're learning, but like the base word is learn. So what STEM does is it takes learning and just instead of writing learning, it just takes it as learn. Like break it down. We don't need the ing at the end of it. The ing is absolutely meaningless. The only thing we need there is learn, and we are able to understand what it means. So this is like the most foundational part of how like a lot of these like large language models we use work. For example, ChatGPT, Gemini, and all of that. So this is just like the inner workings of how they were trained, how they were created. So this year I had to import Porter Stemma and initialize Porter Stemma as PS. Now Porter Stemma takes the tokenized uh words and then it's stem it, just stem. So I just said, okay, PS of stem token. It just takes the word and take the base word and that's it. The original word and turn it to the base word and that's it. And then after tokenization, the next thing you do is lemmatization. So lemmatization works very similar to stemming, but what it does is it stem the word to a more meaningful base form. So unlike stem, unlike stemming is quite like basic. It's not intelligent. It's not smart enough to differentiate like, for example, commands, commander. It's not smart enough to differentiate between commander and commander. If you just write the command, if you remove commander, commander is not even important to it. But in lemmatization, it to keep that word commander because it feels like okay, that commander is actually like a different word, and it really help us in training our model of this NLP. So that's what like lemmatization does. So I think I've really gone through the very basics of NLP, which is like you clean the data, you remove noise, and we've already like prepared the data for training our models. Now, from here, it's easy to start doing like exploratory data analysis, which is like you can now start checking words and deriving like statistics from it and all of that. So one of the ways to get information from the word or like necessary information from the word is something called engrams. So engrams helps to check how often a word occurs. So if you want to know how often like a particular word come up or how often like people type a particular word in the review, we use something called engrams and um this is it right here. So for here I initialize a variable called unigram. Now unigram is like checking okay how many times the one particular word showed up. So it just check okay. I created like a series to be able to just arrange them accordingly from the highest to the lowest. And as you can see here, we see that hotels is the most common word used here, followed by room and then great. Now from this data, you guys will realize something. Most of the reviews that this hotel was getting are very good review. It's so easy to tell because great was one of the words that was used there. Hotel, I don't know. Hotel obviously is an hotel, so they'll have to say, okay, the hotel, blah 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 blah, and then room because in an hotel you obviously use a room, so you talk about the room, so that's why like it's occurring more. But aside that, the important stuff which is great is super like occurring, so which means data has great reviews, and then stay also has great reviews. And for not, maybe I don't know what I might have, but it's a lot. It showed up a lot, sha. So for this one, it's just check diagrams. How often do two words um um occur? So if as you can see here, great location occur together several times, several times, several times. And the hotel Monaco staff friendly occur several times. Now all this means is okay, the hotel is probably located in a very great place that makes sense. And then the space is I don't know what that one I mean, but like it makes sense, right? I guess. And then we have staffs are friendly, which means like the staffs are very friendly and all of that. Look decorated, occurred once, every other thing occurred once. But one thing that really occurred more was great location. A lot of people like the location, which is like so obvious. So you can always like, give a visual representation of your n-grams or yeah, of your n-grams. So n-grams is just like okay, n grams. It can be as much as let's say you want to see how often five particular words occur at the same time. You can down like what's it called? Okay, let's leave that one. Let's leave that one. I'll try to look at unigram, bigram, trigram. Um, what's four? I forgot it. But anyways, like so this one here just give like a visual representation instead of just showing us number, right? Which might not be understandable to like layman. If they see this frequency, they will understand that okay, hotel occurred a lot in the review, followed by room, then great. But as you can see, great occurred a lot, and then good too occurred a lot. Even location occurred a lot, and staffs too. So a lot of people talked about the staff, the location, and how good the hotel is, and how great it is, and all of that. So yeah, that is it for that is it actually for now because these other ones here are quite like complex and I wouldn't want to go through them because I want you guys to understand the whole of this STEM, tokenization, Regex, data cleaning and all of that. So do anyone here have a question for me about a place that they might be finding hard to understand? I'm waiting on. Do anybody here has any question for me? You guys understand what I've like thought so far? I need like chat, chat response, like type, type. Hello. Are you guys even still with me? First, are you guys still with me? Yes. So I'm asking, like, all right, good. Uh, so NLP is like broad, and NLP just means like natural language processing. That is like taking a natural language. It can be English, it can be Chinese, it can be Japanese, it can be Yoruba, whatever. And then we are taking that language and then we are training it, right, for the computer to understand it. And so like NLP just helps us to understand how we, filter the words that are important to be able to train it for a model. So there are so many ways you can conduct research on NLP. You can decide to conduct research on NLP on your own language, like your native language, and make it like better so that let's say you want to create a system where your people can be able to communicate to the AI in their language. It's easier for the AI to understand. So yeah, like there are broad places you can do NLP research, but one of the most common places obviously is the large language models. And large language models are like very big data. They take a lot of like spaces and all of that. So to be able to train large language model, you need to have like large storage. You need to have like, you know, a lot of these necessary like tools, like what's it called? This Nvidia chips and stuff like that. Yeah, or you can also take advantage of like cloud sources also. So like yeah, it's just that this NLP is just the basics. It's just the like fundamentals of how like a lot of these things work. So do anybody here have a question, please? You can talk, oh. You can interrupt me, you can type. I I honestly wanted this to be very interactive, but I guess we'll have to get used to each other. So yeah, any question really? Any other question? I would like to hear from Emmanuel. Hello, are you guys with me? Uh, okay. Let me check. Let me check. Hmm. So if you want to search for like a significant gap or significant research gap that I can do or dive into, it's something you have to research. Something you have to research because there are like so many things that a lot of people have done with NLP already. So you can always like research on it to get like to know exactly which part you want to research on. Yeah. So before we actually like finish, I want to great. Please, can you please unmute your mic? I want to know, is your laptop with you like now?
No, sir, I'm joining the meeting with my phone right now.
Okay. So the reason why I was asking is because I wanted you to like show because a lot of people did not really were not able to finish the agricultural predicting modeling, and I wanted you to like show them how you were able to submit and all of that because even on my own side, like it's not working, and I have no idea why. it's not working. So like,
Okay, let me see if I can access it from my phone. A moment,
okay.
please.
Are you able to get it?
It's loading up. Is it okay for me to share my screen?
Yes, you can. That was why I said, yeah, you can share your screen.
Okay, it's up now. So I'm not sure, but there might be some issues trying to submit via mobile. I know that the mobile app does not open projects. It asks you to open it via desktop, so you can only access it through web if you're using a phone. I've not tried submitting through the web version before. I've only used my PC. But
Okay.
I think that the project checker basically checks the answer itself. So I think it just checks to see that in the dictionary named best predictive feature, you have your keys, your key set to K, and then whatever value you have for your um, accuracy, because different metrics will give you different values for the accuracy. So I don't know, should I just go through my process and show what I did?
Mm, yeah, for the sake of like the other people that were unable to submit.
Okay. All right. So um, basically, what I understood from the project was that um, a farmer, the real world project is to help a farmer out with his farm. Now, the farmer has metrics that are measured from the soil, the nitrogen level, phosphorus level, potassium level, and pH. These are the various metrics that can be measured from the soil at any given time. Now, the levels of each of these elements and the pH level as well determine which crops would do best. And I'm guessing that with seasons or with kind of fertilizers and stuff that you use, the composition of your soil will change with time, also with location. Now, the problem is that it's expensive to keep gathering data of every single element and the pH um, across your farm all the time. So to make it cheaper, the farmer that we are working for wants to gather data for just one feature. So either nitrogen or phosphorus or potassium or pH, just one, because it's cheaper to gather data for one as against four. So our task is to find which of these features um, would give us the best results if we are using just one feature for our model. So that's what we're trying to figure out. So right off the top, we import our dependencies, import Panda, import log regression, import twin test splits, and our metrics. I went ahead to import F1 score because F1 score was my preferred metric of choice at the time. Then we load our data from the CSV file into a PD data frame. Then what I did next was to explore the data to have a brief look at what I was working with. So because I'm using my mobile device, the data is not going to show fully. We will not see all the headers fully. But basically here we have index. Then I think the first column is um, phosphorus. No, it's nitrogen, then phosphorus,
Nitrogen,
then yes, then
potassium,
potassium,
then the
then
pH, and then
pH.
the crop.
Yes. So the last one, crop, gives us the crop that performs best given these particular measurements. So for this row, the zeroth row, when we have when you have nitrogen at 90, potassium at 42, phosphorus at 42, potassium at 43, and pH level of 6.5, the crop that does best is rice. So for all the other ones under here, we have rice. Then I used describe to see what the data looks like, see how much each of these data points vary, and we can see that for nitrogen and potassium, the data is quite similar. Our minimum is 0 for nitrogen, max is 140, phosphorus we have 5, 145, um, potassium we have 5, 205. The difference is not much there, but for pH, the difference is quite much because we can only have pH from 0 to 10, I believe. Then
Yes.
so I did crop
No,
slot
0 to
info
7.
0 to 7. Oh, we have, okay. Oh, yeah, 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 yeah. Is it? I'm not sure. Here we have pH of 9.9 as our marks.
Okay, miss 0 to 10. 0 to 10.
Then I checked, I did cross on info to confirm that there were no empty cells. We didn't have any known um, entries and confirmed that we did not. Then I wanted to know I wanted to know what the crop distribution was like. If it was just like binary classification, maybe we were just dealing with rice and beans. So I checked how many unique entries we had under the crop feature. And it turns out that we have 22 different crops. So it's obviously not binary. So I printed out the number to confirm that there are different crops and maybe not just maybe difference in spelling like rice and rice with an S, you know, mistakes like that. Confirmed that they were all unique. Then I checked the counts for each of the crops, and it turns out that the data is evenly distributed. So we have 100 entries for each of the crops. So from there, I moved over to preprocessing, and um, all I did here was to encode the label. So I wanted to convert these names, rice, grapes, mangoes, into numerical data. So that's what I did here. And sorry, give me a sec. All right. So um, after encoding the label, next thing I did was to split the data, and I set stratify to Y
Wait,
so that
wait.
we have
Great,
yes,
great. Did you
yes.
encode everything before you split the data? Like everything,
I encoded the label,
like
yes.
all the data that was, that that's
Everything
like
on that crop.
what you should have done. So normally, what you should have done was you should have uh what's it called? Process it like using that LLM encoder. You should have done it after test. You fit and transform. But then when you are doing it in your test set, you just transform it. Because in real world
Oh,
data, like to you have to make sure that you are testing on original data. So most times like you don't just transform everything all at once. When you end up
oh,
training it, you probably end up overfitting. So like next time
oh,
take notes.
okay,
Yes.
okay, okay. Thank you,
So
sir.
you reprocess after you split it. That is
All
like
right,
change
okay,
it, standardize, like maybe use a standard killer, min max and all that.
okay, sir. Okay, thank you, sir. So, while
Yeah, go on, go
splitting,
on. Don't worry.
okay, I set random states so that whenever I run it, I have the same outcome. Then I set stratify to Y so that we have equal distribution for each of the crops in both between and the test, and we don't have more of something on one pass. Then I instantiated my logistic regression using multi-class since we are not dealing with like binomial classification. Then this is where the bulk of the work was. So you can ignore lines 2 and 3. In line 1, I set F1 to an empty dict. Then I started a for loop where I looked through each of the names of the columns. So basically, for each iteration of the loop, I'm picking one feature. So the first feature is nitrogen. So during the first iteration, feature in x dot columns is going to be equal to n. So X train selected, this is where I select what I'm training with per iteration. So X train selected would be X train would be a data frame of X train feature. So for the first iteration, feature is equal to n. So for the first iteration, X train selected would be a data frame that only contains the column n. Then X test would be the same thing, X test for just the column n. So I fit on X train selected and fit on Y train, and then I find the F1 scores and um, add add that to my dictionary, my empty dictionary. So I add it in the format feature and then F1 score, so that when I'm looking at it, I know what score is for what feature. this part is for me so that I can look at it and be sure that this is the max score. So that's the iteration that runs. So for each iteration, it picks one feature and trains and sets the F1 score. Then when I did the project at first, I just used F1 score. Then later, I also used accuracy score. So that's why we have two extra digits in lines 2 and 3 there. So I also added those in just to see what they would look like. So after that, I printed the dictionary that I created here to see what it looked like. And then, from printing it, you already can see what the highest score is, and you can manually create the dictionary with the correct feature and the correct score. But considering that in a real world scenario, you might have a situation where you're dealing with lots and lots and lots of features. So it may be impossible to go through each feature one by one to confirm which has the maximum score. So I did a different loop for that. So I created an empty dictionary best predictive feature. This is what is required by the um, by the project. The last instruction here is from this information, create a variable called best predictive feature, which should be a dictionary containing the best predictive feature name as a key and evaluation score, whichever metric you choose as the value. So I instantiated an empty dictionary with that name, best predictive feature. Ooh, it's going to take a while to load. Sorry about that. So I instantiated um, an empty dictionary and then I started running another for loop. So in the for loop, I was iterating through each of the keys and values. So through each key value pair of the um, of the dictionary from my previous loop, where I stored all the accuracy metrics. So for each key value pair, it's for all the values rather, it checks if um, for each key value pair, it checks if the value which we are iterating through is the maximum value in that dictionary. So if it is the maximum value, it then um, appends or it imputes that key value pair into the empty dictionary best predictive feature. And that was how my best predictive feature was set with K as the key and then my accuracy value as the value. And that was it. When I submitted, it worked. So it's still taking time to load. I'd like to show the last.
Thank you, great. So for people that are unable to get it, if you are with your system now, I would advise you to share your screen so we can deal with whatever issue that is you know get it. So Grace, you can stop sharing your screen. Thank you for that. I really appreciate it.
No problem.
So yeah, so you guys have like seen how Great was able to solve it. One of the key things there I saw that you guys should take note of was actually the processing of the data. You need to make sure you convert the data you need to normalize the data, make sure that all of them are actually in numbers, in very similar numbers, so that you can be able to train the data properly and get a more accurate um result. So any of you here that unable to solve it, I would say now you can share your screen, you can talk on what issue you are having. Else, I'll just wait for like 3 minutes and we'll end the call. I'll send you attendance also, and then we'll end the call. So I've dropped the link to the attendance. You can view. Yeah, thank you for that. Yeah, 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 yeah. So the link to the attendance is there. So you guys can fill the form. We'll just wait for the next. I'll just give you guys 5 minutes and then I'll end. Um, Great. Please, I want to ask a question. Last breakout session, nobody was here. Were you guys able to do anything, or you just ended up leaving?
No, sir,
Hello.
we were not able to do anything. Last week was it was peculiar. First of all, the email that comes every weekend with the links for each of the breakout rooms did not come. So first
Okay.
we were unsure about whether or not the breakout sessions were holding at all. And then if they were holding, we didn't know if we were to use the same link from the previous meeting. So personally, I don't know about others. Personally, I kept on using the link for the previous meeting because I sent the link to the group for somebody that was having difficulty joining 2 weeks ago.
Link
So
for
I kept
previous
on
meeting will
joining.
never work.
So there was
Link
no
for
email
previous
with
meeting will never work.
there was no email.
The reason is
Okay.
because
So there
like
was no
they
link
always
sent
create
for
a
last week, and I think one or two. Yeah.
new one, so you can record the classes. So now, like, I think I'll be the one to get more because the other thing that most people they are so you guys can get from me now. I would really try my best to share those and I was really paying that I did that because that I had like my plate like some kind of deadlines and let's catch up with. So yeah, so yeah. And you guys should please like communicate more on the Discord page because it's very important for us to know how like you guys have been catching up so far. You know, it's very very important. So we can make sure that everybody on the same page. Because it will be over in like December, I also finish every single thing necessary for us. So we can, have that issue proud of we are sure, something like that. Fill the call and you can actually leave or done for today. I I'm glad we had this conversation. I'm glad I was you guys.